Good afternoon, everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture series, I'm going to explain about time division multiplexing, where multiplexing, it is nothing but a medium can carry only a single signal at any second in time. To transmit multiple signals in a medium, the medium has to be separated by providing every signal a segment of the whole bandwidth. This can be possible by using a multiplexing techniques. Multiplexing is a technique which is used to combine various signals into a single signal using a shared medium. There are different types of multiplexing techniques like time division multiplexing, frequency division multiplexing, CDMA. It is nothing but a carrier division multiplexes, then a wideband division multiplexing, which are utilized in a data transmission systems. We'll go with the activity now. In a time division multiplexing system, 4 channels are multiplexed to form a single stream of data. Each channel is assigned a time slot in a repeating frame. The frame consists of 8 time slots. Which of the following statement is true? 8 time slots per frame is the correct answer. The time division multiplexing, it is nothing but a multiplexing technique that is used to transmit 2 or above streaming digital signals above a common channel. In this type of multiplexing technique, incoming signals are separated into equal and fixed length time slots. Once multiplexing is done, these signals are sent over a shared medium, and after demultiplexing, they are reassembled into their original format. This is the block diagram of a time division multiple axis. First one is pulse amplitude modulation, then the next one is communication channel, and where it is being sent to the pulse amplitude demodulation. Then it is finally being given to the low pass filter. This is nothing but a block diagram where commutator and decommutator plays a major role in it. There is a various number of low pass filters at the beginning of the system, which is based on the number of data inputs. Basically, these low pass filters are anti-aliasing filters that remove the aliasing of the data input signal. At the receiver end of the system will be after the from the low pass filter output, it is given to the commutator, where according to the commutator's rotation, the data input samples are gathered through it. At the receiver end of the system, a decommutator is used, which is synchronized at the transmitting end by the commutator. So this decommutator at the receiving end divides the time division multiplexed signal. How does this time division multiplexing works? There will be the various number of input sources, that is A, B and C, and it is multiplexed and is given to the various frames. We'll call it as a common channel, that is frame 1, frame 2, frame 3. We'll be sending each time slots, that is we are sending the data in the form of A, B, C, that is A1, A2, A3, B1, B2, B3 and C1, C2, C3. At the same time, the number 1 slots will be sent to the common channel, that is A1, B1, C1 will be. Then it is divided as a frame 2. The two frame data will be taken over there. Then frame 3. Likewise, it goes on. So every individual data stream at the receiving end is reassembled depending on the timing. In the diagram, we have 3 sources, as I said, A, B and C, which wants to send data through a common medium. The signal from these 3 sources can be separated into various frames where every frame has its fixed time slot. In the TDM system, 3 units from every source are taken into the consideration that forms the actual signal jointly. Then a frame is collected with a single unit of each source that is transmitted at a time. When these units are different completely from each other, then preventable signal mixing chances can be removed. Once a frame gets transmitted above a specific time slot, then the second frame utilizes a simple channel to get transmitted, and further this process is repeated until the transmission is completed. The main advantages of time division multiplexing is it uses the total bandwidth of the channel for signal transmission. Time division multiplexing systems are very flexible compared to FDM. For every channel, the complete available channel bandwidth is used. Sometimes the pulse overlapping can cause crosstalk, however, it can be decreased using the guard time. The drawback of the TDM is nothing but both the transmitting and the receiving sections should be synchronized properly to have the right signal transmission and the reception. The TDM is complex to implement. Then this systems require addressing the data and the buffer. In TDM, synchronization is very significant. This is the various applications. It is used in telephonic systems and various utilized in wire telephone lines, and it is also used in fiber optic communication, radio, digital and the satellite communication. What is mean by assessment? What is mean by TDM? And what is the main role of commutator we use in the time division multiplexing block diagram? Thank you.